Okay, let's get back to it. So we're looking at number 9, and we're multiplying two polynomials together. That's what these things are called. So we've got this term, and so this polynomial has two terms, so it's a binomial. This one has three terms, so it's a trinomial. So what I'm going to do is I'm going to take each term, I'm going to call this kind of the extended distributive property of one binomial, and of the binomial, I'm going to multiply it into the trinomial. So the arrows indicate places where I'm going to multiply. So the first thing I'm going to do is multiply 2x times 4x, and 4x squared, and I get 8x to the third power. Then this next one here is going to give me a minus 2x minus 18 x to the second power. 2x times a negative 13 is going to give me a negative 26x, and then 3 times 4x is going to give 4x squared, that is, pardon me, is going to give me a positive 12x squared. Keeping it moving, 3 times negative 9 is a negative 27x. 3 times a negative 13 is going to give me a negative 26. And so I have 6 terms. Which are related to the 6 arrows that I've drawn, and I'm going to join my like terms together. So this is an x squared term, this is an x squared term, this is a x term, this is an x term, and finally this is a constant, and this is a x cubed term. So what I realize is that this guy has no partner, no friend. You don't have any friends, and so you're just going to be by yourself. All right, so there's no like term there. And then now we're going to take the x squared term, because notice we're going to go in descending order. 3 is the highest power, 2, then the power of 1, and then no power at all, meaning a power of 0 for the x term. If that doesn't make sense, chapter 7, I promise it'll all make sense. All right, so when I join my like terms here, I end up with a negative 6x squared. That's from these terms here, and I already took care of this. And my x squared term, my x term, pardon me, is going to come together to give me a negative 53x. Those guys are there, and minus 26. So that's my answer for number 9. Number 10 is very similar in that we're going to have to do this extended distributive property where we're multiplying binomials or multiplying polynomials, in this case 2 pairs of binomials. But then after we do that, we're going to join like terms together, and we'll see what we get. So let's see how this works out. So again, I'm going to take 3x multiplied by 4x, and then maybe I'll actually do that. 3x times 4x and 3x times 7. 3x times 4x gives me 12x squared. 3x times 7 is going to give me a plus 21x. And so now that I've done that, let's go ahead and multiply negative 10 times that, negative 10 here. When I do that, I get a negative 40x, and then I get a negative 70. So I've dealt with this first part. Now I'm going to deal with this other equation over here. So I'll start off by taking 2, multiplying 2 into each of the terms of the other equation. So 2x times, and I'm just adding it to it, 2x times 4x is going to give me 12x squared. Then 2x times 8 is going to give me a plus 16x. Finally, let's use orange here. We have 5 times this, and then 5 times that. 5 times 6x is going to give me a plus 30x. And then 5 times 8 gives me a plus 40. So you can see by the color coding where we got all these values from. At this point, we're going to join like terms together, do what we got to do. And when we join our like terms together, then we get this expression down here because we have joined our like terms together. So the 12x squared and the, what else? The other 12x squared gives me the 24x squared, positive 21, negative 40x, positive 16x, and the positive 30 come together to give me 27x, and then finally negative 40 and a positive 70. Wait a minute. Oh no, yeah, this 40 and this positive is this negative 70 come together to give me negative 30. So I've got that, and so that's number 10. Let's take a look at number 11. Number 11 is also a wonderful example of something that you will see in chapter 7. So you know, it's worth your while to take a look at those chapters, those sections, and see what makes sense from it. So basically, what we know here is that we can look at this as a fraction, right? And we could reduce 9 over 21. We'll deal with the x's and stuff later. 9 over 21 can be reduced to 3 over 7. So that's done. There's nothing else to simplify there. Now we got to deal with these exponents. There are some exponential rules that you're going to see in section 7172 that would really address all of this. I'm going to give you the answer, ask you to take a look at those rules. Basically, when we have a negative exponent, it tells me to take the whole thing and move it to the other place. So this is in the numerator, I'm going to move it to the denominator, and then the exponent becomes positive. So I took this and moved it down. This guy is going to be moved up, so that's going to be x to the 4th power. This y to the 11th power stays there, and this y to the 5th power goes there. I know right now you're pulling your hair out and you're wondering why, but just stay with me. Trust me, if you watch the video, it will make total sense. So then I'm still hanging out with my 3/7, but these guys are going to cancel out to give me x to the 2nd power in the denominator. Why is that? Because if I've got 4 x's at the top, 6 x's at the bottom, cancel, 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 I'm left with 2 x's at the bottom. And then here I've got 11 x's and then 5 x's altogether. That's 11 y's and 5 y's altogether. That's 16 y's. So this is my answer. All right, let's look at the other page. This is also work from chapter 7 that you need to think about. Basically, we're trying to figure out what do we need to multiply here in order to get to this. But let's figure out what exactly is going on here. So this is actually 3 to the 2nd power. Again, rules from chapter 7. 3 to the 2nd power, x to the 2 times 3 6th power, y to the 4th power. And I'm multiplying it by some stuff. And I'm going to multiply it by 4xy to the 4th power. And I want it to equal to negative 180 x to the 11th, y to the 13th. So here's what I know. I know that 9 times 4 is 36. In order to get that 36 to become a 180 or negative 180, I'd have to multiply by 5. And you could do a little bit of division to figure that out, okay? The next thing I need to do is say, well, I've got x to the 6th times x to the 1st, which is x to the 7th. In order to get x to the 11th, I need x to the 4th, all right? And then finally, y to the 4th times y to the 4th gives me y to the 8th, but to get up to the 13th, I need y to the 5th. I know this is terribly sloppy, so I'm going to write the answer over here, little arrow, and the answer is negative 5. That's how I get 9 times 5 times 4 gives me 180, or gives me negative 180. And then x to the 6th times x to the 4th, times x to the 6th times x to the 4th times x gives me x to the 11th, and then y to the 4th times y to the 4th, which is y to the 8th times y to the 5th, is going to give me y to the 13th. All right, I'm going to erase this work because it is blocking the other stuff we want to talk about. This is going to be a little bit more involved. This is more chapter 8 that we're looking at here. Chapter 8 says that we are supposed to simplify this. The only way we can simplify this is a rational expression, a rational expression. The only way we can simplify this is by factoring the numerator and denominator, and that's something that some of you didn't talk about, but here's what I'm going to show you. I'm going to factor this, and then we'll talk about what to do next. So with a little work, I factored, and this is what I get. I get 3x plus 2 times x minus 7 to factor this part, and then 3x plus 2 times x minus 5 to factor this part. I can cancel them out because it's the same thing. What does this mean? What are you doing, Dion? Well, if I had 4/8, right, you guys would automatically tell me the answer to the reduced, this is a thought, this is not a part of the problem. You would tell me that the reduced way of writing that is 4/2. Technically, what you guys actually do is you figure out what's in here. You say, well, there's 2 times 2 up at the top, and at the bottom there's 2 times 2 times 2, right? Nobody ever does this, but this is technically what you're doing. And then you cancel. You say, oh, well, blah, blah, blah. For me, it's like a zot, and I get to Zeus, and 1/2, and la la. All right. So you end up with 4/8. And what's happening is we factored this and we canceled out the common factors, all right? Because that's in essence what you're doing. This should be a bigger thought than I had there. In essence, that's what you do every time you reduce fractions. Let's keep going. So we're subtracting this from this. This is an interesting way of putting this. I know that everybody in our class can do this subtraction work. However, the way it's put might lead you to get the wrong answer. So if I subtract something from something else, that means this is the thing that I am that should come first, right? I'm taking this away. So subtract this from this. It's like take $5 from your $5,000 bank account. You know what I mean? Something from something else, right? All right, they don't care. 3x squared minus 5x minus 2. You leave that in parentheses and you subtract the other thing. 14x squared minus x plus 3. Now peep game. What you need to do is, this is actually pretty simple. You can take the parentheses off the first term, okay? but then you're going to distribute the negative through, because when you subtract a sum or a group of something, it's like you are distributing a negative 1 through it. So we get minus 14x squared plus x minus 3. Minus 14x squared plus x plus minus 3. Okay, so now this looks like a dubious little symbol here. I don't know what I ended up, I think it's a minus, right? Okay, so now that you have that, you're just going to join like terms together. These guys are going to come together to give you a negative 11x squared minus x in this, so these guys are gone, minus x, 5x in that is going to end up with a minus 4x, and those guys are gone. And then finally minus 2 in that is going to give me a minus 5. And this is the solution when I subtract this thing from this thing, okay? From the line, blah, 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 find the slope, x and y intercepts. Well, we have done this. This is fun and kicks and giggles. To find the slope, I think it's easy to solve for y because we want it in y equals mx plus b form. So we would get the slope, and then from there we would get the y-intercept. And then we can find the x-intercept by putting 0 in for y and then solving, okay? So we have a bit of a plan. So if I'm going to solve this, 5x minus 3y is equal to 11. I'm going to get that by itself by doing minus 3y is equal to a negative 5x plus 11. Divide both sides by negative 3, and I get y is equal to positive 5 over 3x minus 11 over 3. So I have both things here that I talked about. I've got the slope, and then I have the y-intercept, which is here in red, negative 5/3. And then the final thing I need to do is find the x-intercept. And we said to find the x-intercept, we plug in 0 for y and then solve for x. And I can do that in any equation. Let's just go ahead and do it here. I'm going to use this original equation. So 5x minus 3 times 0 equals 11. Well, 5x obviously now equals 11. X is equal to 11 over 5. And that's my x-intercept. So I have solved it by the three colorful circles are your answers. All right, I'm going to erase it. I'm trying to keep our space, keep the problems at the fore and keep our space clear. So I'm going to erase all of this and get started again. Let's see where we're at. So we've done this guy, this guy, this guy, this guy. We're here at number 16. Let me slide up. So number 16 has this weird subtraction problem. You know that this is a fraction. So it's like a fraction, right? It really is. You can't cancel the x's out and the y's out. Don't do that. That's a fool's errand. When you cancel, you are actually dividing. But you cannot divide that which is added to something or subtracted to something, right? Keep that in mind. That's like one of my top pet peeves. Even up to calculus students still want to cancel out the x. You can't do it. But this is a fraction, and to add or subtract fractions, we need a common denominator. So what I would suggest, quick and easy, is to say, okay, this is going to be x minus y over x minus y. That's what I'm replacing 1 with, minus x plus y over x minus y. So this is just the same, and I replace the 1. I'm looking for a common denominator. Now I see that I'm subtracting all of this. Technically this is like in parentheses, and these now have common denominators, so I can put x minus y here and then distribute my x through. So I get x minus y minus x minus y. Did you see that? Distribute through, okay? So distribute through. So x minus y, swoop, delicious. Those two things are gone. Minus y gives me a minus 2y over x minus y, and we're done. All right, so that was number 16. Here, solve for x. To solve for x, basically, you guys know what to do. This is a literal equation. I'm going to scooch down a little bit, and I'm going to do number 17 down here. So let's see. Okay, rewrote the problem highlighting the value that we're trying to isolate, which is x. First thing, get all the terms with the x on it to one side and get everything else onto the other side. And you can see we've done that here, all right? Now we're going to join these terms together, but it's kind of hard to, sometimes you can't do that. In this case, actually, you can. If I've got 3bx minus 7bx, that is a negative 4bx, okay? So I'm going to do negative 4bx, sorry about the red color, and this is going to give me a 9c, all right? I need to get x by itself, so I'm dividing both sides by that negative 4b, and hopefully you guys can see that x is equal to 9c over 4b. Another video is coming. I'll see you guys soon.